Hello everybody and welcome to section 2. We're going to cover minerals. So what does it mean to be a mineral? You need to be naturally formed, solid, inorganic, with an ordered internal structure and a specific chemical composition. Yeah. We're going to play a little game here in order to cover this in a little bit more detail. I know this is coming at you guys a little bit quickly to kind of get a feel for exactly what this means, what is a mineral and what is not. Natural, solid, not organic, nothing living about it, ordered structure, and a specific composition. So, what about ice? Is ice a mineral or not? Ice. So, ice is naturally forming, not organic, orderly internal structure, crystalline structure, specific chemical composition, and solid. So we will say, yes, ice is a mineral. Usually when we talk about minerals, we're not including ice in this. This one is kind of unique, but from our definition that we're using, ice is a mineral. How about bones? Would bones qualify as a mineral? The answer is no. Why? These are organic. These are formed by organisms, or animals mostly, that are going to be forming these bones. What about water? Is water a mineral? The answer is no. Water is not solid, so it cannot be a mineral, even though ice is. Ice is solid. What about this? This one is a little tougher. Fossil. Is fossil a mineral by our definition? Fossil. The answer is maybe. The answer is sometimes you can have a fossil which is entirely made of minerals. A lot of times what is preserved in a fossil is not the original material, which is organic stuff. Instead, what happens is the original material might make a cavity of some sort or a shape inside of the rock, and then that shape is filled in with something different from the surrounding rock. So then when we go back and look at it now, you find it in the field, you see it preserved somewhere. What you're seeing is a bunch of minerals that has been cast in the shape of whatever living parts were there. But you're maybe not seeing the original organic material itself most of the time. This does happen occasionally, though. Usually what's going to be preserved best are the hard parts of whatever organisms. So some animals we believe to be like this. See, it has this hard shell, the armor up here. This armor actually is preserved as the original material. It is that durable. In a couple cases, we actually can get the original organic material preserved, but this is rare. This is not most fossils at all. How about coal? Is coal a mineral? The answer is no. And the reason why is that coal is organic material. Coal is the remnants of usually plants. They die in a swampy area. They float down into stagnant water all the way to the bottom. There is nothing there to eat them. There is nothing there to turn the water over and to get oxygen down there. They're buried without having exposure to anything that would react with it. It gets buried under more and more plant material as things die, sinks deep into the ground, compresses into coal. This is organic, so it is not a mineral. How about quartz? Is quartz a mineral? And the answer is yes, quartz is a mineral. I'm not going to say the pun, don't even think about it. Quartz is a mineral that we're going to talk about quite a bit. It is pretty common in the crust. It is 1 silicon, 2 oxygen, defined chemical composition and structure, solid, inorganic, naturally occurring. Quartz is a mineral. What about steel? Is steel a mineral? The answer is no. Steel is not a mineral because, as you can see, this is man-made. It is not naturally occurring. Therefore, it is not a mineral by our definition. Next section, going to be a long one, I'm warning you. I'm going to be talking about mineral characteristics.